first presentations in this conference. And today our topic is towards personalization, personalizing e-quiz bank for primary school students. It's an exploration with association rule mining and clustering. It's a collaborative work with Yinfei, Sam Chu, and Bob, and we are all from University of Hong Kong. Of course, we'll talk about some context, then the research questions, followed by methods, results, implications, and conclusions. So what is this e-quiz bank? It's an online system. We call it Reading Battle, and it is designed to motivate ratings of primary school students, and some of our users are even in the kindergarten level. So we use the gamification to motivate them. So this is screenshots of the system, and this system actually included both English and Chinese books. As you know, in Hong Kong we are a bilingual society, and the system contains more than 500 books as of last year when this paper was written. And those books were organized into 23 different categories or genres, like folklore and fairy tales, science, and so on. For each of the book, we motivate them by designing questions. Each of the book has 30 questions designed by experts, and we organize those questions into 4 different difficulty levels, from the easy level to difficult level. And all the questions are organized into 4 different categories, including information search, interpretation and synthesis, inference and evaluation. And so those are designed by experts. And as you can see, the complexity level just increased here. As of last May, this system has been used by more than 30 primary schools in Hong Kong and Taiwan, and with more than 4,000 student users. And for that, we accumulate a lot of system records, like their book reading records and question answering records. So, well, you can see this system is being used very well, and our use base is still expanding. However, there are some things to improve of the system. One thing is personalization. Currently, our system ranks these books in the same order for all the students, all the users. And for the questions to be answered, they are just randomly selected after each book is written, is read. So in other words, there's no personalization. But we think students are different, and it's better to personalize their experience. And now this is our work. We just set out with the goal. We wanted to be able to mine some rules that we can use to recommend the books or the questions to the users. And the secondary goal is to look at the system records, the user interaction records, to discover some knowledge, to know how the students are doing. So there are our research questions. First, what kind of books and questions have the students read and answered? Second, are there interesting association rules among the books the students read? And are there interesting association rules among the questions the student answered? With those rules, we will be able to add a recommender engine inside the online system. So it's going to be more interesting, and we will motivate even more the students. The specific data set we used for this study is just a subset of the system records. And we focused on 523 students because those students filled out an online questionnaire on reading habits. And also they gave us explicit consent. Well, we just come out of the keynotes, right? We used the clustering methods to group those students with similar reading habits based on their responses to the questionnaire. Particularly, we used the agglomerative clustering methods because it's more flexible in deciding the number of resultant clusters. After that, we applied the association rule to the data, the association rule mining to the data. So association rule is like something like this. It's called premise implies conclusion, which means if the premise happens in the data set, that implies the conclusion will happen in the data set as well. And in our context, an example rule would be like this. So if a student read books in category A, this student is likely to read books in category B. So as you can see, this kind of rule would be very handy in terms of designing a recommender behind the system. Okay, then the algorithm we used is called frequent pattern growth, or also called FP growth. I wanted to point out that the term frequent pattern, because the entire thing is based on frequency. So if some pattern happens frequently in the data set, then it will be mined as a part of the rule. So if something doesn't happen that frequently, it will be filtered out and you will not get it into the rules. So later on, we will see the result. Sometimes we don't see any rule, and that's because something doesn't happen very frequently. Okay, so this is our result. It's a demographic of the student users. The gender is generally balanced. I wanted to point out most of the users are actually coming from primary 5 grade, which is equivalent to grade 5 in the American system. So perhaps for primary school students at that age, they are good at using the online systems by their own, and they are really motivated by using these online tools. Okay, this is the result for student grouping or clustering. So those are questions we ask in the online questionnaire. It's basically asking how much time they spend reading different kinds of materials, and also how often they read those materials. There are a couple questions on TV playing, watching TV, how many hours they spend on TV and how many hours they spend on games. And this shows the result. This orange line is cluster 1, and we can see the students actually spend more hours on reading and more frequencies on reading. So this cluster referred as good reading habits, and we have about 90 students in this cluster. And the middle one is the largest cluster with more than 300 students, and their answers is in the middle, so we call it moderate good reading habits group. And the last one is this one. They have few hours spent on reading, but spend lots of hours on TV and games. So for this one, we can refer them as the bad habits group. They have like 100 something students there. But in general, we hope they can improve. Okay, so that's the results for the student grouping. Okay, for the rule mining, this is the general overview. We can see that we actually did the rule mining with the data of all students, that's this row. And we also did the rule mining within the data records within each student clusters. And we can see here, if we look at all the students, there are very few rules in the book category or individual book. But if we look at the records within each cluster, so we did get more rules. So what this tells us, remember just now we talked about the frequency. So that basically means when you look at all the students, they just read different books. They read books in different categories. And as a result, not many of these categories are frequently read. But if you look at each of the clusters, there are frequently read categories and books. So that means the students, if they are in the same cluster, they actually share a lot of interest in common. They read the same book or same categories more often than students in other clusters. And okay, now today we are going to cover in the next few slides those mined rules. We'll look at how the rules look like. This is on the book level, and this is only on the book category level, because individual book, again, the data is too sparse, and we cannot get any meaningful rules. But for category levels, we have some good rules here, and I don't even have enough space to write all of them. here. But one thing I want to point out, all of this, you see Chinese characters, right? So all of these categories are the rules are on Chinese books. That means these students, indeed, they read Chinese books more often. There are fewer records on English books, then it's difficult to get meaningful rules. Another thing I want to point out is the numbers. So cluster 1 is our good habit group. They have 46 rules mined. For the one with bad habits, only 2 rules. That means our students in the good habit group indeed read a lot more, and they have more rules. And in terms of our goal, we want to do recommender system. Then of course we can apply those rules within each of the clusters. Like the first one, if the students is in class 1 or class 2, and if the students read a fairy tale, we can recommend the folklore books for them. But what if they run exhausted of their rule, like this group, the 2 rules has been applied, then we think we can apply the rules in the second cluster to them. After all, these clusters have better reading habits, and we hope those kind of rules can help students in the last group. Okay. Then this is the rules for the question level. In this screen, we look at the question difficulties. Remember, we have easy questions to most difficult questions. And this screen, we look at the questions in Chinese. So these annotations reads like this. So it's answering level 1 Chinese questions correctly. So the R means correct. So then, for example, the first rule actually reads, if a student answer level 1 Chinese questions correctly, these students were likely to answer the level 2 Chinese questions correctly. Okay, then let's see. This group of rules actually give us a symmetric relationship among those levels of questions, which means for level 1, 2, 3, whichever level you answer it correctly, you will get the other levels correctly. So it's actually symmetric. And what this tells us, it means level 1, 2, 3 Chinese questions, they are not distinguishable by the students. So whenever which one you answer correctly, you will answer the other ones correctly. So this actually signified that the design of the questions may not be very suitable for the students, because these 3 levels, they are supposedly to have different difficulty levels, but to the students, they are not that difficult, and they are all in the same similar level. But the situation is different if you look at these rules. This basically means if you want to get your level 4 questions correctly, you need to answer like 2 other levels correctly. And this one means if you answer level 4 correctly, you will get level 1, 2, 3 correctly. So that means level 4 indeed is more difficult, but level 1, 2, 3, we may rethink about it. How about the situation for for English questions? Okay, they are here. So we can see that the premise is a condition, this is conclusion, and we can see that always the premise is in a higher level and the conclusion is in a lower level. So this actually means for English questions, the difficulty level is better designed and better scaled. So if a student answer higher level, difficulty level question correctly, the students will answer the lower level correctly, but not the other way around. Okay. So that's about the difficulty level of the questions. This is the categories of the questions. So we have information search question, we have interpretation question, we have inference question, we have evaluation question. So the annotation reads like this. You answer the evaluation type of question in Chinese correctly. So this is the notation. Then this part actually tells us if you answer the evaluation question correctly, the students will likely to answer the other type of questions correctly. And this actually indicates that evaluation kind of question may be of higher level of complexity. Okay. And in terms of recommendation, so if a student has answered evaluation type of question correctly, and chances are these students will answer other type of questions correctly, then what should we do to keep these students being challenging? Then the recommendation will be, okay, climb up one level of the difficulty, because the categories doesn't make a difference for the students anymore. This set of rule actually shows, for English questions, well, the information search kind of questions is more straightforward than other types, because once you answer other types correctly, you will get the information search type correctly. So this is more straightforward, and it's actually according to our common sense. What about this in the middle? Again, it's something we call symmetric. That means the left-hand side and the right-hand side, they can reverse their positions. That means for Chinese questions in inference, in information search, in interpretation, these three categories, they're interchangeable. So the students answer one of these categories correctly can get the others correctly as well. Again, this means we may need to redesign these kind of questions to keep the student challenged. So a recap of what we talked about so far, the implications of this analysis to the design of the system. We need to redesign some Chinese questions for the three difficulty level and the three categories we just talked about. Then for recommender functions, we know that for both languages, we no need to give questions in a lower difficulty level if the students have answered the higher difficulty level correctly. And also, if the students answer evaluation Chinese questions correctly, then the other types will be easy, and so we need to boost up the students' difficulty level. And for book category recommendation, we can use the rules we mind. We can directly use those rules. Okay, as a short conclusion, we show that the clustering and association rule is taking effective, and we wanted to emphasize that this study actually provided evidence that learning analytics can be pushed down to the primary students level, and some of our users are even from the kindergarten. And for future work, now we have accumulated more data, and so we can mine more rules, and we can implement these recommenders and actually evaluate it with the students. Okay, so that's all for the presentation. Thank you.
Okay, we have time for 2 questions, and there are 2 people with their hands up. So could I ask you to speak into the microphone, please, because we're live streaming.
Thank you very much. John Fritz from the University of Maryland. I'm curious, how many of the texts were electronic, if any? And did you consider mining that data to supplement the survey and performance data for insights on students' reading habits?
Okay, thanks. So you mean the books, electronic? Actually, there are only small part of the books are electronic. It's about 30-something electronic books. Others are actually physical books. But all the schools participating, they have one copy of all the books in their school library. Yeah. That's part of the project. By the way, this project is supported by the Education Bureau in Hong Kong, so they're very helpful on this.
Conrad Hughes, Learning Objects. The question difficulties that you applied then were expert generated, and have you considered looking at machine inferred difficulties in your work?
So far, it's only expert generated. We would be interested in having machine help us, maybe as suggestions that would speed up our process, I think. But right now we haven't done that. But we would appreciate further suggestions on this automating the process. Thank you.
Thanks again, that was fantastic.